So now we'll look at a human application and torque within our body. So this is a model of the elbow joint. Your humerus and ulna are actually radius. And one of your biceps muscles, biceps brachii, I will say. And so when you're lifting a weight, which is the pink ball in this case, the pink ball exerts a force, an external force straight down due to gravity. And the torque is force times a moment arm, and we call that external moment arm the EMA. And so the moment arm is from the joint center to the line of action of the force, and that it is the perpendicular distance. So this external force and the external moment arm create an external or gravitational torque. And so we have three torques in these three situations of from flexion, 90 degrees of extension, full extension. And so the question is, are the torques the same? And indeed, the torques are not the same because the force is the same in all three cases. The pink ball is the same weight, but the external moment arm changes. So it's shorter here than it is in the midsection, and then it's back to short in full extension. All right, and then that external moment arm is countered by internal or muscular torque. So when you're lifting a weight, you're working, quote unquote, working out your muscles, and they are creating internal or muscular torque. And so the force is due to your muscles, so the internal or muscle force, and your muscles have this very small moment arm. Okay, so the perpendicular distance from the center of rotation to the line of action of your internal force, or the IMA, the internal moment arm. And again, throughout the range of motion, your internal moment arm changes, and therefore your torque changes. For internal torque, your torque also changes based on muscle mechanics, which we'll get into later in the course. All right, so this is let me